Hey everyone, let's go ahead and title these notes Lesson 2.4 Literal Equations and set them up in your Falcon Notes formation with a line drawn vertically all the way down your paper and horizontally across the top of your paper. So we'll start off with our essential question, how is solving a literal equation similar to equations involving one variable? So here's a new term for us, literal equation. So the first thing we want to do is define what a literal equation is. A literal equation is an equation that has more than one different variable. Remember, our term variable here just represents our unknown. A variable is our letters. So this could be X, Y, Z, it could be K, it could be any letter that you want it to be. If it's an unknown, it is known as a variable. So we have a bunch of different types of literal equations, but our most common types are formulas. A few examples of literal equations are A equals 1/2 base times height. This is our formula for the area of a triangle. We also have D equals RT. This is a formula for distance. And then we can also have literal equations that aren't formulas. For instance, if we had 3x plus 2y equals 5, that's a literal equation. So some non-examples of literal equations, equations that aren't literal equations, would be like 2x plus 5 equals 7. This is not a literal equation because we only have one letter in here. 3y minus 4 equals 8. Again, this is not a literal equation because we have only one letter. Whereas in our actual examples, in the first one we have A, we have B, and we have H. Those are three different letters. Then in our second one we have D, we have R, and T. Again, three different letters. And then in 3x plus 2y we have X and Y, two letters. So a literal equation is something with more than one variable, more than one different variable. So that's what we're going to be working with today. So with literal equations, our goal is to solve for just one variable in that equation. And we've kind of already been solving equations, so we know what it means to solve for something. To solve means to get whatever variable alone on one side of the equal sign. So we're going to start off with a few simple examples. Our first one is D equals RT, and we want to solve this one for the variable t. So I'm going to highlight the variable I want to solve. So in solving literal equations, we can solve these almost exactly the same way as we would solve normal equations. I'm going to first split my equation up into a left and a right side, just like I've been doing when solving equations with just one variable. Now my goal is to get t by itself, but I have this r that is attached to it. Now I don't see anything added or subtracted in between the r and the t, and typically what that means for us is that this is actually being multiplied, r times t. So I'm going to rewrite this as d equals r times t. So if my goal is to get t by itself, and I have this r being multiplied, in order to get rid of multiplication, I need to divide by r. So I'm going to divide both sides by r. On the left-hand side of my equation, I have d divided by r. Those are different variables, so we can't combine them. So what we do is we just leave it as d over r, and then equals. And then on the right-hand side, we have r over r. Those cancel out, and we're left with just the t. So my answer is d over r equals t. So let's look at our second example, a equals 1/2 b times h. We want to solve this for h. So that means I want to get h by itself. So I'm going to first split my equation up into a left side and a right side. Left and right. The first thing that catches my eye here is this 1/2 because I do not like working with fractions. So I want to get rid of that fraction the first thing that I do. And in order to get rid of 1/2, I can actually just multiply by the denominator. So my denominator here is 2. So I'm going to multiply by 2 on the right side, and I'm also going to multiply by 2 on the left side. So when I multiply by 2 on the left side, I'm left with 2 times a, or just 2a. And on the right side, my 2 and my 1/2 cancel each other out, and I'm left with b times h. So I'm still trying to solve for h here. I still want to get h by itself, but I have this b attached to it. So the b is directly next to that h. Again, there's no plus sign, there's no minus sign in between them. So that means that they are being multiplied. So I can actually rewrite this as b times h. So I have 2a equals b times h right now. So I need to get rid of that b, and in order to get rid of multiplication, I do the opposite. I'm just going to divide both sides by b. So on the right-hand side, my b's cancel each other out, and I'm left with just an h and an equal sign. And on the left-hand side, I have 2a on top and b on the bottom. None of these things can be combined. A and B are different letters. 2 doesn't combine with any letters, so we just leave it as 2a over b, and that is our final answer. So let's do a few more examples. This will be example 3. I'm going to have 3x plus 2y equals z, and I want to solve for y. All right, so I have 3 letters here. I have x, y, and z, but my goal is to solve for y. So I'm going to, again, split my equation up into 2 sides, the left side and the right side. So I need to get this y by itself, and right now I can't really do anything with that y because that 2 is attached to it, and so is this 3x. So I'm going to first get rid of this 3x, and since my 3x is positive, I'm going to subtract 3x on both sides. So my 3x's cancel each other out. My 2y gets brought down to the next line. And then I have z minus 3x. Z and x are just totally different letters, so we can't combine them. And the 3 is attached to the x, so we can't really do anything here, so we just leave it as z minus 3x. So I'm still trying to solve for y, but I have this 2 that's attached to it. And again, it's directly attached to it. There's no plus, there's no minus sign in between it. So that tells us that they are attached through multiplication. So this is really 2 times y equals z minus 3x. So if I want to get rid of this 2 out in front, I need to divide both sides by 2. So my 2's cancel each other out, and I'm left with just a y equals, and then z and 2 don't combine, and then 3x and 2 don't combine. So we just leave this as z minus 3x over 2, and that is our final answer. So sometimes I think that literal equations might be a bit easier than normal equations because we don't have to do as much combining. So let's do one last example. Let's do by plus 2 over 3 equals c. So this is a literal equation because we have y and c. And in this equation, I want to solve for y. Oh, we also have b in there. So I want to solve for y here. So I need to get y by itself. I'm going to split my equation up into 2 sides, a left and a right side again. In order to get my y by itself, I first need to get rid of this 3 because with that 3 being divided, there's really nothing that I can do. So in order to get rid of this divide by 3, I'm going to multiply by 3 on both the left and the right side. So what this does is it makes my 3's on the left side cancel out, and I'm left with by plus 2 equals, and then c times 3 is just going to be 3c. We usually write the number before the letter. Now I still want to get y by itself, but I have a b and a plus 2 attached to it. We always want to get rid of the thing that's either added or subtracted first. So in order to get rid of this plus 2, I'm going to subtract 2 on both sides. I bring down my by because I haven't used that yet. My 2's cancel each other out. And then 3c and 2 don't combine because those are not like terms. They do not have the same variable. So we can just leave it as 3c minus 2. Now the last thing that I need to do is get rid of this b. And again, the b is directly attached to the y. There's no plus, there's no minus in between, so that means that they are attached through multiplication. So I'm going to rewrite this as b times y equals 3c minus 2. And in order to get rid of that b, I need to divide. So I'm going to divide both sides by b. My b's cancel out, and I'm left with y equals, and then 3c minus 2 over b is my final answer. So in summary, when solving literal equations, we basically use the same steps as when we solve equations containing one variable.